Okay, okay. Please accept the recording. Okay, good evening, everyone. In this today's session, we'll discuss a problem related to Bayesian inference. So, this problem says from all population, 1% of people have a certain genetic defect. 90% of tests of the gene detect the defect true positive. 9.6% of the tests are false positive. If a person gets the positive test result, what are the odds they actually have the genetic defect? So now we'll go by one statement of this problem. From all population, so sample space is the whole population. 1% of people have a certain genetic defect. So if there are 100 people, 1% of the people are zero point 0.1 probability of people having any genetic defects. People are suffering, 1% people are suffering from some kind of genetic defect. Now it talk about in the next statement, it says 90% of tests for the gene detect means now we are talking about the detecting the gene detect means we are performing some tests to identify a gene detect. So that test can be defective, that can be test can be a positive. Means sometimes test is accurate, sometimes test is not accurate. So if test is accurate, then we call it accurate test. When it's not, we call it a non-accurate. Now here comes the topic true positive and the false positive. Means true positive means if there is gene detect and the test is detecting that gene detect, that is a true positive. Means already there is certain things and it is detecting that. And 9.6% test as false positive means whatever the test is there, but it is not able to. Uh, People are not suffering from the gene detect, but it is showing the people have a gene defect means a person who has no defect but after the test his report is positive, so that is also positive possible because sometimes test is not so much accurate. So, and the last statement it asks if a person gets a positive test result, what are the odds they actually have the genetic defect? Means it is asking probability of having a genetic defect given that person test is positive. So it can be a true positive, it can be a false positive, but it is talking about the whole positive statement. Now we'll go one by one statement. So first we'll define some event here. So, chance of having the faulty gene is 1%. From the statement, 1% of people have a certain genetic defect. So, if we'll define it as a, then probability of A will be 0.10. Now, we can derive that a person is suffering for faulty gene 1%. The person is not suffering from faulty gene is a 99%. The probability of A equal to 0.10 and probability of not A equal to 0.9. Now we'll assume that a positive test result is X. Now we'll proceed further. Now the next statement says true positivity of test for gene defect detect is 90%. So you can rearrange this sentence. Chance of a positive test result given that person actually has the gene is 90% or probability of having the gene given a positive test result is 0.9. So we are deriving probability of having the gene defect given a positive test result is zero point 0.9 probability. Okay. Next statement is false positivity of test for gene detect is 9.6%. You can rearrange the sentence. Chances of positive test if the person does not have the gene is 9.6%. So you can see that here is a certain event is not having the gene defect, that is a not A, and it is calculating the probability of positive test. So you will get a probability of X given not A, that is 0.96. So we have these values P of A 0.10, P of not A is equal to 0.99, and P of X given probability of X given A is equal to 0.90, probability of X given not A 0.96. Now we have to calculate if a person gets a positive test result, means it is certain that he is going for the positive test result. So we have already assumed X as a positive test result. What are the odds they actually have the genetic defect? So for finding out the probability of genetic defect, given person has a positive test result. So we have to find probability of A given F. Now we'll apply the formula. So here a formula can slightly will different. So you can find out as per Bayes theorem, probability of A given X equal to probability of X given A into probability of A. This was the old one. Now there is slightly different. So in a denominator part, we have to derive probability of X given A into probability of A plus probability of X not A into probability of not A. Now we'll put all the values here and we'll get this result. So you can find out that there is a slightly difference in the equation and so on. So for the next session, we'll solve this problem and thank you.